Hello everyone, welcome back. In this video we are going to learn how to apply a Seaborn theme in order to plot figures. First of all, we are going to import necessary libraries. We are going to import Seaborn, Matplotlib, NumPy and Pandas. And in order to generate sample data, we are first of all having the random seed to be, for example, 42. It's an arbitrary number. We can change it. We can put 50, for example. It is ensuring the reproducibility of our data. So whenever I have this line of code, this random seed, it means that if I run the code several times, like if I run it again and again, it is going to have the same points on the plot for me, so the same data is used. Okay, so when I run the code one more time, you see it again here. But when I comment this part, if I comment this part and I run the code, we see different numbers in every run. So you see that different points are being shown in every run, so the points are being changed. Okay, but because we would like to ensure reproducibility, we are going to have the random seed from the NumPy library. Then we are going to have the generation for the x variable. We are going to use the line space function from the NumPy library to generate 20 evenly spaced numbers, let's say points between 1 and 10. Okay, then we are having y to be equal to the sine wave with some noise, and this is the function we would like to plot. Okay, and now we would like to create our data frame based on the data that we generated. So that we call the data frame function from the Pandas library. We call the data frame df, and we are having the x values and the y values that we generated just here. Okay, now we would like to apply the Seaborn theme and to style the plots. So we call the set theme function from the Seaborn library. We are having the style to be dark grid. We are having the palette to be deep, and this is the name of the font. So the style is dark grid, but there are different themes that are available. So when I run the code, this is, for example, my theme now. For example, if I put white grid instead of dark grid, you see that the grid is changing. Okay, so we can have, for example, a dark here. So when I run, you see that the grid is changing. So depending on what we are looking for, we can of course play with the style, and the palette is the color of the plot. For example, of the line here, you see the moderate blue, but I could have, for example, muted, bright, pastel, dark, or colorblind. For example, I put the bright instead of deep for the palette. So when I run the code one more time, you see that the color is brighter. Okay, this is also what we want, what we can choose. So we can choose the palette as we wish, and this is the font. We can change the font as we would aiming for. Now I would like to create my figure and axis for plotting, and the size of the figure I would like to be 8 by 5 inches. Then let's plot a simple line using Seaborn. So I call the line plot function from Seaborn library. The data for my plot is from the df data frame. X is x values that we created from the data frame df, that here we assign it to df. Y is y values from the df data frame. The marker is O. We are having the creation of the axis, and the label, we call it line plot. So when we look at this part, we see that we are having a line plot shown in blue. So this is the line plot. As we see, the x generation of numbers are, this is the x-axis and this is the y-axis. For the x-axis, we see that we are between 1 and 10, as we were aiming when we were generating data for x. We said 20 evenly spaced numbers between 1 and 10. So we exactly have between 1 and 10, 20 evenly spaced numbers. Okay, and we are having the label here, the line plot. So this is the line plot label. We are having the X values and Y values from the DF data frame. So we created the data frame here. X values and Y values are X and Y that we had earlier generated. And for the marker, we are having O. We could have, for example, X. So if I run, you see that we are having times there. So let me first comment the part that is for the scatter plot. So when I run the code, you see that here the markers, for example, if I have the O, for example, you see the marker is like O. We can have star. So the marker is a bit different, but because of the coloring, it's not very obvious. So if I uncomment the scatter plot, you should be able to see the star. Okay, you see the star. Okay, so the star is there. So depending on what we are looking for, we can have it there. So I would keep it with O because it's, I think, nicer, but you can modify it as you wish. Then, so this is everything about my line plot. Now I would like to have the scatter plot. Okay, so the scatter plot with the same data. I'm using the scatter plot. I'm calling the scatter plot function from the Seaborn library. The data equals the DF data frame. We are having the X values, Y values. I would say the color is red. We can change it however we want. The size is 80. So the size of the red parts are 80. We can have it to be, for example, 500. So it's much bigger. When I run, you see that they are much bigger. So if I downsize it too much, they are not even shown there. So it's not even possible for you to see them. So you need to find a trade-off there. So maybe 70 would be a nice number to start with. And also we label it to be scatter plot. So scatter plot is with the red dot, and we see the red dots in the scatter plot in the plot here. Okay, so far we learned how to have the line plot, how to have the scatter plot. Now it's the time to set the title. So set the title function for the X axis. For the plot, sorry, we use the AX that we created here above with the size. Okay, so this is the AX. So I would like the title of the figure to be simple Seaborn plot with Seaborn set theme, and the font size to be 14. So I can change the font size, but 14 is nice. So this is how we can set the title. We can label for X-axis and Y-axis. So set X label, set Y label. We're having X-axis, Y-axis, and also the font size. So the X-axis is the name of my X-axis. I can change it to be time, for example. So I can put, instead of Y here, you see that the label of the Y-axis is Y-axis. I can say years, for example, just something to show you here, years. So you can also modify this part. And this function is going to help me to show the legend here. So we are having the legend. So we know that the red dots are for the scatter plot, the blue line is for the line plot, for example. And finally, in order to show the final plot, I use the show function, and we are going to have the show function from the Matplotlib library. So we call the show function from the Matplotlib library, and we see the figure here. So in this video, we learned, first of all, how to generate sample data, how to create our data frame, and we learned how to apply Seaborn theme to style the plots, and we created the figure and axis for plotting. And here we were having the details of the line plot, here we were having the details of the scatter plot, and here we were having the customization of the plot. So in this video, we not only learned how to plot a figure using Seaborn and using the set theme, We also reviewed some NumPy functions, NumPy library functions. We also reviewed the Pandas data frame function. And also we used, let's say, the Matplotlib library show function to plot our figure. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to have a coding exercise with scatter plot using the Seaborn library. So first of all, I'm going to import the necessary libraries: Seaborn, Matplotlib, NumPy, and Pandas. First of all, I'm going to set a Seaborn theme for better visualization. So I call the set theme function from the Seaborn library, and I put the style to be white grid, the palette to be muted, and the font to be serif. And there are other options that we can try for each of these styles that we already discussed in other videos. Now we would like to generate our sample data. In order to generate a sample data, we can have the random function and then the seed function from the NumPy library to put a number there to ensure reproducibility. This 42 is an arbitrary number. We can put 50, we can put 60, whatever. But when we are having this line, if I run the code like 100 times, it is going to generate one set of data and give it to me every time that I run the code. But if I comment this, it is going to generate a whole new data every time that I run the code. Okay. So because I want to have the reproducibility, I'm going to have this line. Then I would like to generate 100 random values between 0 and 10. So between 0 and 10 for the X and Y coordinates. Okay. So originally it is going to generate numbers when we are using the rand function from the random and NumPy library. It is going to generate me numbers between 0 and 1. But if I multiply it by 10, it is going to give me the numbers between 0 and 10. So it means that, for example, the first time it is going to generate x equals 0.5. So it is then multiplied by 10 and it will be 5. Okay, so the number is between 0 and 10. But originally the generated numbers are between 0 and 1. But when we are having the multiplication by 10, the numbers will be between 0 and 10. Then we would like to generate 100 random marker sizes between 0 and 300. Okay, so 100 random marker sizes between 0 and 300. It is going to be generated here. And we would like to randomly assign one of the categories to each data point. So we are having our data points, because now we created 100 x coordinates and 100 y coordinates. So we are having 100 points, and randomly these 100 points are assigned to A, B, and C. So the size is 100 because we are generating 100 numbers. So in order to randomly assign them to 3 categories, we are going to have the choice function from random function from the NumPy library, and we are assigning the name of categories. Now it's the time to create our data frame to organize the generated data. Now we call the data frame function from the Pandas library, and the data frame is called df, and we say, okay, the x values that are generated, assign them to the x values. The same goes with the y. The marker size we generated here, assign them to be the size, and then the categories we generated them here, and it is assigned to be the category. So it is going to group the variables. Now it's the time to create our figure. Now here we are defining the size of 8 inches wide and 5 inches tall. And then now we're creating the scatter plot that we were looking for using Seaborn. So this is first of all the scatter plot that we see here. In order to do that, we call the scatter plot function from the Seaborn library. We assign the data frame df to be our data. The x-axis and y-axis, they are getting the x values and y values. We are having the who equals to be category, meaning that different colors represent different categories. You see here, for example, category A has the color blue, category B has the color light brown, or let's say orange, and category C has the color green. So you see that here we are having the category to be the hue, meaning that different colors are going to represent different categories. Then we are having the marker sizes based on the size column, and then we are having the alpha, which is the level of transparency. So it is something between 0 and 1. 0 means fully transparent and 1 means fully opaque. So when I put it to be 1, when I run the code, you see that the colors are brighter. But if I reduce this 1 to be 0.1 and I run the code, you see that they are transparent now. So depending on what number you're looking for, you can modify this alpha. We choose the edge color to be black, so we are adding a black border for each data point here, if you see. So when I zoom, you should be able to see the black borders. Okay, and the line width we choose to be 0.5. we can adjust it, and then we are assigning the plot to create the axis object. Then we are here having the title. Using the set title, we are titling the plot, so we are having the scatter plot example. This is my title being shown here. Then we are having the font size, which is 14. Then we are having the x-axis, y-axis, and the font sizes here and there for the x-axis and y-axis, and here is the title. We are having the legend being shown there, so we are having the legend. This is my legend, and the title of the legend is category that we choose here. Finally, we use the show function from the Matplotlib library to plot our plot. Okay, so basically this is how we can have our plot being there. We are having different sizes. You see some of the data points are smaller than the other ones because randomly they are generated, and we are having 3 categories. So in this video we learned how to plot a scatter plot in Seaborn library. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about line plots. So first of all, we need to import necessary libraries: Seaborn, Matplotlib, NumPy, and Pandas. Let me show you the figure, and then we are going to discuss how to plot it. So this is my figure. You see that I'm having a figure with 2 line plots, a sine wave shown in blue, and it has a solid line, and we are having the cosine wave here shown with the orangish color, let's say, or light brown we could say maybe, and it is shown with dashed line. We are having the title here, we are having the y-axis, we are having the x-axis, and we are having the generation of x between 1 and 10 for both figures. And we see that here we can have 2 line plots in one figure. But how can we do that? First of all, we are going to set a Seaborn theme for better visualization. We are having the style to be white grid. We are having the palette to be muted and the font to be serif. Then we need to generate the sample data. In order to do that, we are having the random seed to ensure reproducibility. Then we are using the align space function from the NumPy library to generate 50 evenly spaced numbers, or let's say points between 1 and 10, and this is assigned to x. We are having the sine wave with noise for y1. We are having the cosine wave with noise for y2. Then we are going to create a data frame for the data. We are having the data frame function from the Pandas library, and the data frame is called df. we are having the X values for both lines here. We are having the Y values here that are stacked Y1 and Y2. So Y1 and Y2 because we are concatenating them. And also we are having the label of each group. So the one group is sine wave and the other group is cosine wave. So you see one of them is sine wave, the other one is cosine wave. Okay. Then we would like to create a figure and axis. In order to create the figure and axis, we are having the fig and ax. We are having the subplot function from the Matplotlib library, and this is the figure size 8 by 5 inches. Now it's the time to plot a line plot using the Seaborn. So we call the line plot function from Seaborn. We are having the data to be equal to the df data frame that we created here. X equals X values in the data frame. Y equals Y values. We are having who equals category, so it is going to generate different colors for different categories. So you see that the colors are different. So we are having two colors. Then we are having style equals category, so it is going to have different line styles for different categories. So you see that the blue one is a solid line, the other one is the dashed line. Okay. Then we are having the markers. We say, okay, markers equals true, so we would like to show markers at each data point. So we see that here we are having one marker, another marker, another marker. So these dots are marker. So the marker style here in the blue line or sine wave, it's O, but here it's a star. So depending on what we want, we can choose different markers style, but here we simply say that okay, just put the markers to be true. So I would like to have markers so I can see the data points. Then we are having the line width, so the thickness of the line is now 2. It can be any number, for example it can be 5, so it will be thicker. You see that when I run it's thicker. It can be like 1, so it's thinner. So you see that it's thinner. So depending on what we like. And we are having the axis assigned to Matplotlib axis. Then we are having the title of the figure, line plot example with Seaborn line plot function. So this is the title and the font size is 14. We are having the x-axis label. So the x-axis, we write the label to be x-axis and the font size is 12. So this is the x-axis. We are having the y-axis. So the y-axis, we call the set x label, set y label to have the labels for x and y axis. And then finally, we're going to have the legend to be shown. So this is the legend that we see here. And finally, we are going to call the show function from the Matplotlib library. And in this example, we saw that we can have multiple lines in one plot using the Seaborn line plot function. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about how to plot a bar plot using Seaborn library. So first of all, we are importing the necessary libraries: Seaborn, Matplotlib library, NumPy, and Pandas. Then, in order to set a Seaborn theme for better visualization, we are having the set theme function for using from the Seaborn library. We are having the style to be equal to white grid, the palette to be muted, and this is the font. Then we are having the generation of the data. So here, first of all, we are ensuring reproducibility. This is why we are using the seed function. So every time that I run the code, it is going to give me the same data. But if I comment this line, every time that I run the code, it is going to generate me a new set of data. Then we are having the categories being generated. So we are having, for example, 5 categories: A, B, C, D, and E. Then we are having some random values for each category. So we would like to have random values for each category A to from A to E actually. And you see that this is my category A, this is my category B, category C, category D, and category E. And the numbers are generated here up until 80. But if I comment this part, for example, and I run the code one more time, we see that, okay, now we are having around 98 maybe. So because the upper bound for us is 100. So when I run the code one more time, we see that, okay, so we are having something like 12 and we are having around 60. So depending on the generated data, we're going to have different values, and we see that it is going to be directly come from this line because we're generating 5 values in this range for these 5 categories. But if I comment this part, uncomment this part, when I run the code, you see that this is the new data that is generated. Okay, but if I run it one more time, 2 more times, 3 more times, you see that the same data is there. So this is the usefulness of the seed function when we are putting the seed there. Then we are having the data frame being created. So in order to create the data frame, we call the data frame function from the Pandas library. We call the data frame name to be df, and we are having the category in the data frame is the data from the categories that we got, and the value in the data frame is the value that we generated here in this line. So now we created our data frame. We can also, if we want, to print the data frame as well. So I can also print the df. So when I run the code here, first of all, we are going to see the data frame actually that we are going to work with. So the category, you see here is the column for the category from A to E, and here is the column for values from 61 to 30. So the first row is having the A to be equal to 61. We see that A it's 61. We are having B 24, so B is 24. We are having C 81, so we see it here. So this is the data frame that we use to create our bar plot. We can always print it to make sure that the data is consistent. And then we are going to create a figure and axis. In this line we are having the 8 inches by 5 inches. Then here we are going to create the bar plot using the Seaborn. So we call the bar plot function from the Seaborn library. The data equals df, and for x we are having the categories. So you see that categories A to E are on the x-axis. The y-axis are the values. So the y-axis is the values, and we are having the color to be sky blue. So I choose sky blue. We can change it, of course, to whatever we want. Then we are having the alpha, which is the degree of transparency. It's between 0 and 1. I put it to be 0.8. The closer it is to number 1, the brighter it will be. And if I have, for example, number 1, now that I run the code, you see that it's brighter. Let's say it is less invisible, but if I put it down to 0.1, you see that it's like a shadow. So you can also adjust this number as you wish. We are having then the edge color, which is black. I choose to be black, so you see that the edge color, it's black here, it's totally black. Then we are having the line width to be equal to 1. We are having the matplot axis being assigned. Then we use the set title function to put the title for our plot, and also the font size 14. So bar plot example with Seaborn.barplot function. Then we are having the X label and the Y label. So X label, Y label. Here we are having category and value, and the font size we are putting it here. And finally we are having the grid. So we say that for the grid we are having the axis Y, So, and the line style to be dashed line. So you see that these are the grid along the y-axis, and as you see, it's not a solid line, for example, it's a dashed line. And here is the alpha, which is the degree of transparency, to be 0.7. We can change it to 1. So when I run, we see that it's it's more eye-catching. Now, instead of having the dash line, maybe we can try another style. For example, we can have the solid line, and this is what we are looking for example here. Then I use the show function from the Matplotlib library to plot my figure. So in this video, we learned how we can plot a bar plot in Seaborn and how we can do some customization to our plot. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to plot a histogram using Seaborn. First of all, we are going to start with setting the theme for our Seaborn for better visualization. So we are having the set theme function from the Seaborn library. We assign the style to be white grid, the palette to be muted, and the font to be serif. Then we ensure, in order to ensure the reproducibility, we are going to use the random seed 42 from the NumPy library. This 42 is an arbitrary number. We can modify it as we want. Then we would like to generate our data. In order to generate our data, we are going to use the normal distribution from the NumPy library. And we would like to have 500 data points. And we are going to have the average of 50 with the standard deviation of 15. Okay, so this is the data generated and we call it data. So this is going to let's say generate the 500 points and assign it to an array. Now I would like to randomly assign these and generated data for the category group A and group B. So we are having 500, the data set of 500, they are assigned to group A and group B using the choice function, and we are assigning it to our categories. So here you see that we are having the value range, we see that here, and we are having the frequency here as well. Okay, so now we mentioned that we would like to have the average of 50, which is around this point, with the standard deviation of 15. Okay, so you see that they are assigned to different bins as well. And here on the y-axis we are having the frequency being counted, while on the x-axis we are having the value range. So now that we generated our data, we need to create our data frame. In order to do that, I call the data frame function from the Pandas library and assign the name of df for our data frame. And we assign the value in the data frame to be data that we generated here, and the category to be categories that we generated here. Okay, so I created my data frame, but let's print the data frame first. It would be maybe better to see visually what we are having as the data set. So when I run this code, it is going to be having the data frame with two columns, let's say value and category. So here we are having the category, for example, group B is having this number, then group B this number, group B this number, group A this number, and indices they start from 0 and they continue until 499. So we are having 500 points being generated in two columns, values and categories, group A or B. So we are having 500 group A, B, group A, group B, group B, group B, group A, group B, these things up until the end, and we are having 500 points here. Okay, so here we were generating the data. Okay, here we were generating the 500 points, and here we were generating 500 either group A or group B. So group A, the number of generated group A plus B equals 500. Okay, and then we are having here in this column, like one time it's group B, the other time it's group B, the other time it's group A, again group B, A, B, A. Randomly they are generated. So we created our data frame. Now we need to create the figure and axis. We are having the subplot function from the Matplotlib library to have a figure size of 8 by 5 inches. Then in order to create a histogram, we are going to call the histplot from the Seaborn library. We assign the x to be the values. So here is the value, you see. We assign the number of beans to be 30. Okay, so this is the number of beans. So you see that I'm having, for example, 1 bean, 2nd bean, 3rd bean, 4th bean, 5th bean, etc. So if you count these number of beans, they will be 30 as we discussed there. Then we would like to have different colors for different categories here, as you see. And we would like to have the overlay of kernel density estimation, KDE. You see we are having two line plots are there, so you will see them there. So if I comment this part, you wouldn't see the line plots. So when I run, you see no line plot there. So because they were the KDE, and I wanted to print the KDE because from some statistical probably analysis, it will be important to know them as well. So then because I want to have the KDE, or let's say kernel density estimation, I assign KDE to be equal to true. Then I can adjust the transparency to make overlaps visible. So we are having 0.7, so we are having 0.7, but we can of course modify it as we wish. Then we are having the edge color to be black, the line width to be 0.5, we can modify them. Then we assign to matplot axis. Next is the time. Let me comment the code here. Next is when we are having the titles. So I would like to set the title to be histogram example with Seaborn histplot. So histogram example with his Seaborn histplot, and we are having the font size to be equal to 14. We are having the X label here. It's the value range. So I put the label there, and the font size I want it to be 12. Then I have the Y label, or let's say Y axis. So we are having the frequency here, and the font size is 12. Then we are having the legend, and the title of my legend is category here. Then we are having the grid. We would like the grid to be on the Y axis. For example, here you see I would like it to be the dashed line with the level of transparency of 0.7. We can modify any of them if you want. And finally, we call the show function from the Matplotlib library to plot our histogram. So in this video, we learned how to generate sample data and how to use it to plot a histogram. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to work with a kernel density estimation plot, or let's say KDE plot. So here is my KDE plot, and we are going to learn how to plot that. First of all, we are importing the necessary libraries. Then we are setting the Seaborn theme for better visualization. So we are having the set theme function from the Seaborn library. Style equals white grid, then the palette is muted and the font is serif. Then we start generating our data. In order to ensure reproducibility, we use the seed function from the NumPy library. So whenever I run the code, I see the same set of data. But if I don't have that line, whenever I run the code, I see a new set of data being generated. Okay. Then after that, we are going to have the data A, and we are going to generate 500 points with the mean of 50 and the standard deviation of 10 using the normal generation from the NumPy library. So the data A is generated with this policy, and we are having data B being generated again using the normal distribution from the NumPy library, but this time we are having the average of 60 and the standard deviation of 12, while we are having the same number of points, which is 500. Then we are having the labels for groups. So we would like to have two groups, group A and group B. So we are having 500 points as the data A, 500 points as the data B. So in total we are having 1000 points, and I would like to have 500 points for the group A and 500 points for the group B. And we are using the array function from the NumPy library. So we are creating a NumPy array and assigning it the name of categories. Then we are going to have the data frame being called df. So I call the data frame function from the Pandas library, where we are having the values being concatenated for the data A and data B. So we are merging these two data sets, data A and data B. And for categories, we are having the categories that we generated here. So first of all, let's see the output of the data frame. So here is my data frame. There are two columns, value and categories. So we are going to have 500 group A and then 500 group B. Okay, so in total we are having from 0 to 999, which is 1000. Then we are having again 1000 values. Okay, 1000 values are being generated here, and the data that is generated, we see that they are concatenated here. So we are having 500 here and 500 here, but all in all we are having from 0 to 999 that we see here in the output. Okay, so this was my data frame. Now I would like to create a figure and axis. In order to do that, I use the fig and ax and then use the subplot function from the Matplotlib library, and we are having a figure size of 8 by 5 inches. Then we are going to create the KDE plot using the Seaborn library. So the data in the plot equals the df data frame, x equals values. We are having different colors for different categories. Then we are having the adjust bandwidth because it's a smoothing factor here that we are having it. Then we would like to, as you see, we are filling under the curve. Okay, in order to do that, we are having the fill equals true. So fill equals true is going to help us to have the filling under the curve. Then we are having the transparency level here. It's 0.5. We can adjust it as we want. We are having the line thickness, so it equals 2. Then we are having the assignment to matplot axis. So let me first comment the data frame. Okay, so when I run, okay, now I would like to set the title, which is KDE plot example. So KDE plot example with the font size of 14. We are having it here. Then we are having the X label and Y label. So value range and density. So value range and density. And also the font sizes, both of them are 12. Then we are having the legend, which is here. Legend is here and here. And we are having the grid for y-axis with dashed line and the transparency of 0.7. And finally, we plot the figure, the KDE plot, using the show function from the Matplotlib library, and we see it here. So in this video we learned how to create a kernel density estimation plot in Seaborn library. Thank you for watching. Hello everyone, welcome back. In today's video we're going to talk about box plot. So first of all, we're going to import all the necessary libraries. Then here we are having the sample data for the box plot. There are three categories that we are considering in this example: category A, category B, and category C. For category A, we are going to generate 50 random numbers from a normal distribution from the NumPy library with a mean of 10 and standard deviation of 2. This is for category A. For category B, we are having 50 numbers being generated from normal distribution with the mean of 15 and the standard deviation of 3. Finally, we are having the 50 numbers from the normal distribution with the mean of 8 and the standard deviation of 1 being generated, and these are going to be considered as category A, category B, and category C. After generating the data, we are having the creation of our Pandas data frame. So we are having the data frame function from the Pandas library for the data that we created here. And the name of my data frame is df. Okay. Now we would like to set the figure size. In order to set the figure size, we want it to be 8 by 6. And in order to plot a box plot, simply we are going to call the box plot function from the Seaborn library, and we assign the data to be equal to the df, which is my data frame that we created from the data that we generated in data here. Okay, and basically this is it. And we are going to put a title saying that basic box plot. So basic box plot, this is my title here. I'm having a y label called value. So you see that the y axis label is value. And we're going to call the show function from the Matplotlib library to plot the figure. So to plot the box plot. And you see that here is my box plot. Category A, category B, and category C. So these are plotted here simply using the generated data and the box plot function. It's very simple to have that. So category A, category B, and category C. Now what if we want to have a horizontal box plot? Again, we're going to do all the same thing. So we're going to have the data generation, 50 numbers for category A, the same with B, the same with C, but in the first one we are having the mean of 10 with the standard deviation of 2. Here the mean of 15, standard deviation of 3, mean of 8, and standard deviation of 1. We create the data frame, we plot the figure, set the size, we call the box plot function. However, in order to change the orientation here to horizontal, we are having this simple line, orient equals h in quotes. So this is going to help me to have a horizontal box plot. So these are the categories now on the y-axis, and these are the values on the x-axis. Okay, so here instead we are having the value label on the x label. So you see that x label is value, and the category labels are here on the y label. However, previously here the value was on the y label, y-axis let's say, and the x-axis was the categories, and here value was on the y label, but here it's on x label. Why? Because basically we are changing the orientation. So now we know how to first of all create a box plot, and now we know how to change its orientation and plot a horizontal box plot. Now here I would like to give you a bit more concept about the box plot. So here I would like to also, apart from the boxes that we are plotting here, I would like to have the data points as well. It would be sometimes very helpful to give some idea of how things are shown in the figure and how the data is generated throughout the horizon. So here again, I'm generating the data, 50, 50, 50. So 50 numbers for category A, B, and C. The mean and standard deviation, they are not the same. We create our data frame here, and we set the size. And I plot my box plot using the box plot function from the Seaborn library. So data equals df, which is the name of the data frame. Then in order to have the individual data points, we need to call the strip plot function from the Seaborn library, and data equals df. And for the sake of simplicity and for the sake of the fact that we would like to distinguish the points, we are going to change the color. I'm going to run the code now. So when we run the code here, we see that the data points are in grayish color. So if I don't have this line, so if I remove this line, this part of the code, when I run, it is going to give me the data points, but here it's very hard to distinguish the data points because they're having the overlap and the color is the same, so it's not easy to trace them. Therefore, I put the color to be equal to 0.26, so it's a grayish color, so it is easier to find the data points everywhere. So now also we learned how to add the data points using the strip plot function from the Seaborn library. We write down the name of the data frame as the data, and for the color we choose a color different from the original colors of the box plot, so we can easily find the data points. And then we are having the title, so box plot with individual data points. Then we are having the y label, which is value here, and we see it here. And we call the show function in order to plot our figure used from the Matplotlib library. So in this video, we learned how to draw a box plot, how to change its orientation to be a horizontal box plot, and how to show the individual data points. Thank you for watching. Welcome back. In today's video, we would like to talk about strip plots. So first of all, we're going to import the libraries, and let me show you the strip plot. So this is the example of a strip plot. We're having category A, B, and C, and we see that these are the data points on the category A, on category B, and on category C. So, and this is the first plot, and we can have a more customized strip plot, like we change the color, we have a borderline, black borderline, we are having the category B and category C here. But how can we do that? So first of all, we are going to call the seed function in order to ensure the reproducibility, meaning that when we are having a number here, whenever we are going to run the code, it is going to show me the same data. If I comment this part and I run the code several times, it is going to generate the data several times. So in order to keep things simple, we can consider this line of code to ensure the reproducibility. Then we are having the data, so we are having the category and value. For the category, we are having, and these are the categories, so the first 3 data are in the category A, then the next 3 are in the category B, and the last 4 data, they are in category C. Then for the value, we are having the random generation using the NumPy library, and we are generating basically 10 numbers, and each number is going to be assigned to one category. Okay, so first number that is generated is for the category A, the second one and the third one also for A, 4th to 6th ones are for category B, the rest are for the category C. Then we create our data frame. So in order to create that, we call the data frame function from the Pandas library for the data that we are having here, and the name of my data frame is df. Then we are having the figure size 8 by 6 inches. We are calling the strip plot function from the Seaborn library. X equals category. Okay, so the X, we are putting the category for the X. These are A, B, and C. Then for the Y, it is equal to value, that these are the 10 numbers that we generated. And basically for the data, we are having the data frame. And this is the title, so basic strip plot. So you see here, so these are the numbers, the 3 numbers that were generated for category A, 3 numbers that were generated for category B, and 4 numbers that were generated for category C. And we see that the y-axis, the label is value, the title is basic strip plot. So this is the basic strip plot that we are having here. Okay, for the y-axis we are having value, for the x-axis we are having category. So for the x-axis we are having category, for the y-axis we are having value, and the data frame df is assigned to the data. So this is the initial basic strip plot that we discussed. Now let's go and discuss the customized strip plot. So we are going to use the same data that we generated above, and we are going to have the same size, basically 8 by 6. We are having for the X label, we are having the category. For the Y we are having value. The data is from the data frame df. We are having the size to be equal to 8, the color is blue, edge color to be black, and the line width to be 1. It is a more customized version. So you see that the color is blue, the edge color is black, and the line width is 1. So the line width is the width of the edge that is black. So if I increase the line width, for example, here instead of 1, I put 5, you will see that you see much more thicker border line. So you can modify this, and you can, for example, change the color, change the size, etc. So if I, instead of 8, I put 10, for example, and I run, you see that the dots are bigger, so data points are bigger. So this is basically how we can consider having a strip plot, the basic strip plot, and with a little bit more customization. Hello everyone, welcome back. In this video we're going to talk about heat map. So first of all, we are going to import necessary libraries: Seaborn, Matplotlib library, Pandas, and NumPy. Then we are going to set style for a better visualization. We are going to have a white grid. Then we are going to have the random seed 42. So 42 is an arbitrary number. We can change it. It can be 50, for example. But having this number is useful. Having this line of code is useful, actually, because whenever I run the code, when I have this line of code, I'm going to have the same data whenever I'm running the code. So for example, you see this is my heat map. I run the code, I have the same output. I run the code, I have the same output. But if I comment this line and I run the code, now we are going to get, each time we are going to get a new data. So you see the data changes. This is why this line is going to help us to have the same data every time that we run. So we are not going to generate a new set of data every time we run. So I'm going to keep that. Then I'm having the 10 by 10 matrix being randomly generated. The data is assigned to data, and you see that it's 10 by 10. So from 0 to 9 for the x-axis, and from 0 to 9 from the y-axis. So it's a 10 by 10 matrix, and the size of the figure is 8 by 6. And here we are calling the heat map function from the Seaborn library, and we call the data, and also we are having the color map to be viridis. So this is the color that we see here. I'm going to talk about the other options that we have. Then, so the heat map is created now. We have the title here, the basic heat map with random data, and we are calling the show function from the Matplotlib library. And when we run the code, we see the output. But instead of having this color map, we can change it to other colors as well. So another option is plasma. So you see that the data color has changed. So this is plasma. We could have Inferno, for example. So when I run, you see that the colors are different. And we have Magma. So when I run, you see magma. This is the color. And finally, we are having the CVDIS. So when I run, we see that here the color changes. So depending on what we are looking for, we can modify that as well. But in this video, we learned how to have a basic heat map with random numbers for a 10 by 10 matrix with random values. Thank you for watching. Welcome back. In today's video, we are going to work with heat maps with annotations. So again, here we are setting the style to be white grid, and we are having the random seed to be 42. So when I have this line of code, every time that I run the code, I'm going to get the same data. If I commented this line, it means that I'm going to have a new data being generated every time that I run. Then I'm having a 10 by 10 matrix with random values. So random function from the NumPy library is used for a 10 by 10 matrix, and it is assigned to data. And then I have the figure size to be 8 by 6 inches. Then I have the heat map function called from the Seaborn library. So the data is there. So the data that we generated there, it's there. The color map is cool warm. The annotation equals true, meaning that we would like to have the numbers on each cell. Inside each cell, we would like to have the numbers. In order to have that, we need to have the annote equals true. Then we are having the FMT equals 0.2 F, meaning that we would like to have up until 2 decimals for the numbers that are printed in each cell. So 0.2 F, 2 decimals. Then we are having the title, heat map with annotation, heat map with annotations, and we use the show function from the Matplotlib library to plot the figure. So here from 0 to 9, then from 0 to 9, so a 10 by 10 matrix is there, and we are seeing the numbers with 2 decimals. So in this video, we learned how to have the annotations and how to have the up to 2 decimals for the numbers on each cell. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to work with heat map with masked upper triangle and lower triangle. So this is what we mean by heat map with masked upper triangle. So it means that we are putting a mask on the upper triangle so you don't see it, only you see the lower triangle. And if you're having a masked lower triangle, it means that the lower triangle is not seen, but the upper triangle is seen. So let's see how we can illustrate that. So first of all, we are importing the necessary libraries like Seaborn, Matplotlib library, Pandas, and NumPy. And we're going to set the style to be white grid for better visualization. Then we are having the seed to be there, therefore we would like to have the same number being used for every run. If I comment this line, we're going to generate a new data every time that I run. Then I'm creating my data frame called df. In order to create the df data frame, we call the data frame function from the Pandas library. We would like to have a matrix by that is 8 by 8, and we're going to have random values using the NumPy library. We're going to generate random values for a matrix of 8 by 8, and the numbers are between 0 and 1. And here we are having the column's name. Here you see that we are having the var I, and I is in the range 8. Okay, meaning that it is going to start from 0 and it is going to go up to 7. So you see var 0, 1, 2, 3 and up until 7, and here var 0 up to var 7. So var I for each I in the range 8, meaning that we are going to have from 0 up until 7, because the ending point is not included. So ending point is 8, and what we are going to have up until 7. So here we are creating the data frame and generating the name for the columns. Then we are having the heat map with masking. So in order to have that, we call the trio function from the NumPy library, and it is going to help me to have the upper triangle mask because it's a trio function and it is assigned to mask. So then I'm having the size of the figure 8×6. Then I call the heat map function to create my heat map from the Seaborn library. So I'm having the data frame df being called there. Then I'm having the color map to be cooled warm. It can have different options as we discussed before. We are putting the mask of the heat map to be equal to the mask that we created here. We would like to have the annotation to be equal to true, meaning that the numbers we would like to be inside the cells. So we would like to have their print inside the cells. And we would like to have up to 2 decimals. So we see that we are having 2 decimals. FMT equals 0.2f is going to help me to have 2 decimals, and line width to be equal to 0.5. So this is the line width that you see. It can be anything. You can have it to be equal to, for example, 1. So if I run the code, you see that the width is thicker. So if I put it to be 10, maybe you can see it better. So you see that, okay, the width are thicker, so there is more distance between 2 cells. So I put it to be 0.5, and when I run, we see that we are having the cells there. And finally, we are having the title, which is the heat map with masked upper triangle, which is here, and we call the show function from the Matplotlib library to plot our heat map. So this is the masked upper triangle you see here. But if I want to have the masked lower triangle, it's very simple. So instead of having trio, we are going to have trill. So we are going to have triangle. TRI is from the triangle and L is from the lower. So we are going to mask the lower part. So when I run, we see that now the lower triangle is masked. Okay, if I put U means upper, so it is going to have the masked upper triangle. You see here. So it's very simple, and you can generate your data here, or you can simply have your data set here, and then you can plot a heat map with a masked upper or lower triangle. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to work with joint plot. So here is my joint plot. Now I would like to learn how to plot this and what this plot is telling me, in fact. In order to plot this, first of all, we are going to import the necessary libraries: Seaborn, Matplotlib, Pandas, and NumPy here. Then we are going to have the data set being generated. So I'm going to have the same data for the test. So whenever I run the code, when I have this line, we're going to have the same output, you see. But if I comment this line, whenever I run the code, I get a new data being generated. So I would like to have the same data. I keep this line. Then I would like to have my data frame called data from using the data frame function from the Pandas library. We are having the feature 1, feature 2, and category. Basically here we are generating numbers normally distributed, and here we are having, and we call it feature 1. Then we are generating the data for feature 2 using the NumPy library. And here we are having the same number of data, but they are distributed with different mean and they are scaled. So because we wanted to have a little bit of a different data set. Then here in this line, we are creating a new column in the data set called category. Okay, so it assigns random values of either A and B to each of the 200 rows. Okay, to each of the 200 rows, it is going to assign A or B, and the total number of rows remains 200, but the distribution of A and B is random. So imagine, let me illustrate it with an example. Imagine that you have 200 students in a school, and you randomly assign each student to either team A or team B, but you don't control how many end up in each team. It's random. So in the data set here, each row, or let's say data point, is randomly assigned to A or B, just like students being randomly placed into teams. Basically, this line is doing this. Then we are having the set style to be white grid, because for better visualization it would be very much helpful. And finally, we are having the joint plot function being called from the Seaborn library. X equals feature 1, so x equals feature 1, y equals feature 2. This is being printed here. And data of the joint plot equals the data frame that we created here called data, and the kind is scatter. And here is the title that I choose for my plot here: basic joint plot scatter plus histogram. Okay, so this is the title. And finally, I call the show function from the Matplotlib library in order to plot my joint plot. But how can we understand this plot? Let me zoom out a bit so you can see the figure completely. I think it's easier now for you to see the figure completely. Now, looking at this plot, in the center we are having the scatter plot. Okay, we call it center region. So each point represents an observation from the data set. So each point here represents an observation from the data set. It shows the relationship between feature 1 on the x-axis and feature 2 on the y-axis. So the points appear randomly scattered without a clear pattern, because we use the random actually function. This is why we don't have a clear pattern. Okay, they are randomly scattered without a clear pattern. So this suggests a weak or no correlation between two features. Because we don't have any pattern here, this suggests a weak or no correlation between two features. And we are having two histograms as well here, as you see, one on the top, one on the right. Okay, the top histogram shows the distribution of feature 1. Okay, this is for feature 1. And the right histogram shows the distribution of feature 2. Okay, feature 2 and feature 1. And both histograms indicate that the data is roughly normal, because we see the pattern here, we see the pattern of normal distribution here. So they are roughly normal, with most values concentrated in the center. This is one of the features, in fact, of the normal distribution. And some points in the scatter plot here, some of the points, the scatter plot are far from the center, like this one, or this one, or maybe this one, or maybe even this one. Okay, so some of the points in this scatter plot are far from the center, which may indicate outliers. Okay, so this is also how we can understand these plots. So let me review it one more time. Here we discussed a joint plot. As you see here, a scatter plot and two histograms. The scatter plot here, each point on this is representing an observation from the data set, and it shows the relationship between feature 1 on the x-axis and feature 2 on the y-axis. And because we don't have any particular pattern here, we can simply say that there is a weak correlation or even no correlation. We are having the histogram on the top for the feature 1, histogram on the right for the feature 2, and we see the normal distribution in this plot. And some of these points that are far from the center in the scatter plot, they indicate the outliers. So basically, this was how we could have a joint plot with a scatter plot and histogram. We learned how to create the data frame, how to plot the joint plot, and how to understand it. We had some analyzing of this figure. Thank you for watching. Welcome back. In today's video, we would like to talk about joint plot with who, or let's say category differentiation. So here is my plot. First of all, we're going to learn how to plot this joint plot, and also what we can understand from this plot. Okay, so here first of all we're going to import the necessary libraries. We are importing the Seaborn, Matplotlib library, Pandas, and NumPy. And first of all, we need to have the data generation. So we are starting to generate our data here. First of all, we are having the seed function from the NumPy library to be 42. This number is an arbitrary number, so we can change it as we wish. But this line is going to help me to have the same data every time that I run the code. So if I comment this part, or if I remove this part and I run the code for 2 times, 3 times, every time that I run the code, it is going to generate me a new set of data. So I would like to have one data only. This is why I put the seed there. Then in order to create my data frame, I call the data frame function from the Pandas library. I call the data frame data. And in the data frame, I'm having feature 1, feature 2, and category. So in the feature 1, we are normally distributing 200 points, and from the NumPy library, we are having the same thing for the feature 2, but with a different mean and scale. Then we are having the category with size of 200 for A and B. Basically, we are doing this because this line creates a new column. This line creates a new column in the dataset called category, and it assigns randomly values of either A or B to each of the 200 rows. Basically, the total number of rows remain 200, but the distribution of A and B is random, so we don't know how many is dedicated to A and how many is dedicated to B. So you see that here A is shown by blue dots, and B is shown with orange dots. So we are doing this because we would like to have categories with differentiation colors. Basically, this is what we call who in Seaborn. So the who in this joint plot represent the categorical variable category, which differentiates the data points into 2 groups, A, which is shown in blue, and B, which is shown in orange. So after generating the data, we need to set the style. So we put the set the style from the Seaborn library, and we choose the white grid because it helps for better visualization. Then we are having the joint plot function being called from the Seaborn library. For the x-axis, we are having feature 1. For the x-axis, we are having feature 1. For the y-axis, we are having feature 2. So x equals feature 1, y equals feature 2. The data in the joint plot equals the data frame that we created here, and it is called data. Okay. So this data is for the joint plot. This data comes from this data frame that we created above. And then who for category, as we mentioned, we are having the category of A and B, so we want to differentiate the data points. So it helps us to have a categorical differentiation by color. Okay. Then we are having this joint plot with who category differentiation. This is the title that we have here, and it is the subtitle function from the Matplotlib library, and then the show function from the Matplotlib library to have the figure being plotted here. But what can we understand? Let me zoom out a bit so you can see the whole figure. So what can we understand from this figure? This figure is a joint plot with a who-based category differentiation, often used for bivariable analysis. So it helps visualization of relationship between 2 numerical variables while also incorporating the categorical variable. So we see that here we are having the first numerical variable group, which is feature 1, and the second one, which is feature 2. So we can see the relationship between them in the scatter plot. And a joint plot here, it is combining a scatter plot with a marginal distribution on the axis. Okay, so we are having these two figures as well. So here is the figure for feature 2, and here is the feature 1 figure here, as we see it here. And also it allows the visualization of distribution of individual variables while also showing their relationship in the scatter plot. So this is why joint plot are important, because we can see the scatter plot and the individual plot. So here is the scatter plot where we are having the discussion over the category A and B. So both of them, the relationship between them can be distinguished in the scatter plot, but we are having also the individual plot here for feature 1 and here for feature 2. And this in this joint plot, we're having the main plot in the center, which is the scatter plot, and each dot represents a data point here for us. Then the x-axis represents the figure 1, the y-axis represents feature 1 and feature 2, sorry. And we are having two categories, so A, which is the blue dots, and B, which is the orange dots, and they're displayed using different colors. So this shows how two categories are distributed across feature 1 and feature 2. So now we see that the top and the right plot show the distribution of feature 1 and feature 2 respectively. The histograms shaded gray region, okay, you see it here, and also you can see it here, indicate frequency counts for values in each feature. Okay. And we are also having the kernel density estimate KDE curves, the blue and orange lines. We see blue and orange lines. The blue and orange lines smooth out the histogram to show probability density. Okay, and the purpose of using WHO, or let's say categorical differentiation, is that we are having two groups, A and B, so it is going to help us to have the differentiation in different colors. Okay, and this can help us in identifying the overlap or separation between categories, different density distribution across feature 1 and feature 2, or probably possible clustering or trend in the scatter plot. But looking at the data points that are sent, we can see that they are centered around the origin 0 and 0. So this is the 0, this is the 0 of the feature 1, and this is the 0 of the feature 2. We see that we are having a lot of data points here, suggesting this suggests a normal like distribution. So both categories are fairly well mixed, meaning there might not be a strong differentiation between them based on these two features. Okay, the marginal KDE plot, also these two plots, the marginal KDE plots showed that both categories have similar distribution for feature 1 and feature 2 with some minor variation, and this minor variation comes from the fact that we are having the different mean and scale for feature 2, as you see. Okay, and we cannot find any linear trend in the scatter plot. It implies a weak or probably no correlation between feature 1 and feature 2. So in this video we learned first of all how to plot this joint plot, and finally we learned how to analyze this plot that has one scatter plot in the center, in the main figure, and then the feature 1 plot here and the feature 2 plot here. Thank you for watching. Hello everyone, welcome to this video. In today's video we're going to talk about joint plot with kernel density estimation, or KDE. So this is my joint plot, and I would like to first of all learn how to plot this, and secondly I would like to discuss how we can learn from this plot, or what are the things that we can understand from this plot. So first of all, we're going to import the necessary libraries like Seaborn, Matplotlib library, Pandas, and NumPy. Then we would like to generate our data. So feature 1 and feature 2, they are randomly they are generated using the normal distribution. For 200 data points, using the NumPy library for feature 1, and for feature 2 the same thing, but we are having different mean and scale here. Okay, and this line is going to help me whenever I run the code. I'm going to get the same result. If I comment this line or remove this line or delete this line, it is going to generate a new data every time that I run the code. And then we would like to set the style for better visualization. We are willing to have a white grid, as you see. And also we created our data frame here. So data frame function from the Pandas library is called to create our data frame called data. Now I would like to have a joint plot with KDE, or let's say kernel density estimation. So I call the joint plot function from the Seaborn library. And for the X axis, we are having feature 1. This is the feature 1. Okay, this is the feature 2 for Y axis. Then data from the joint plot function is filled with the data frame that we have here called data. And we are having the KDE here because we would like to have the KDE, we would like to have the kernel density estimation, and we would like to fill the under the line plot here. So we fill equals true, meaning that we would like to fill under the line plot. And then we are having the color map to be blue. So you see that the colors are blue here, different types of blue. So for example, dark blue, light blue, etc. So this is my joint plot. This is my title. I use the subtitle function from the Matplotlib library. And this is the title, joint plot with kernel density estimation KDE. And we are also calling the show function from the Matplotlib library to have our figure. But let me zoom out a little bit. So when I zoom out a little bit, we see the figure here. And this figure is a joint figure that uses kernel density estimation, or let's say KDE, instead of a scatter plot to represent the distribution of two numerical values. So this is feature 1 and feature 2. So a joint plot here shows the relationship between two numerical values, and this specific plot does not use a scatter plot, but instead we are using the kernel density estimation, or KDE, to show the density estimation. The main plot here, the main one in the center, this one I'm talking about, show the relationship, show the density of the data points. So we see here, for example, at the point 0 and 2, we are having the most dense around this point. This is the most dense part, which represented by darker region, indicating the higher density. Okay, and the lighter region indicate lower density. For example, here we are having the lower density, meaning that there are fewer data points in that area. And this allows a smooth estimation of the data distribution. And the top histogram, this one, and KDE curve represent the distribution of feature 1, which is on the x-axis, and this one is on the y-axis. This one is for feature 2, and these show how the individual features are distributed. And data, as I mentioned, appears to be centered around 0 and 2 because we are having the darker color here showing the let's say higher density. And then there is a high concentration of data points in the center, as indicated by darker KDE region that we discussed. Also, the shape of the KDE suggests that the data might be normally distributed. Okay, because we are having like a bell here and like a bell here. So it is going to give us this hint that we use the normal distribution, which is indeed true, because actually we use the normal distribution to generate our data set. So basically, in this video we learned first of all how to plot a joint plot with a KDE, and then we learned about this main figure in the center, saying that the higher density is shown by darker color, and it's mostly near the point 0.2 here, and the lighter bluish color, or let's say grayish color, show the lower number of data points in that region. Thank you for watching. Hello everyone, welcome back. In today's video we're going to talk about joint plot with a regression line. So this is the regression line, and we're going to learn how to first of all plot it and how to understand it briefly. First of all, we are importing the necessary libraries, and here we are generating our data. We are having a data frame being created, and we call the data frame function from the Pandas library and name it to be data. And feature 1 and feature 2 are generated, normally distributed data here, and here again for feature 2 we are having normally distributed data with different mean and scale, and we use the NumPy library to generate our data. Then we would like to set the slide to be white grid for better visualization. Then we are going to call the joint plot function from the Seaborn library in order to plot our figure. So x equals feature 1, x equals feature 1, this is the label, y equals feature 2, this is the label. Data from the joint plot function equals data that we created here. So this data is the data frame that we created, which is this data, but this data is the data that needs to be filled from the joint plot. So the data from the joint plot equals the data frame that we created here called data. And we would like to have the regression, so reg represents the regression line. Then we are having the title joint plot with regression line, joint plot with regression line we are having, and then for that we call the subtitle function from the Matplotlib library, and then the show function from the Matplotlib library is called to have our plot here. So if I zoom out a little bit, so when I zoom out you see the figure easily. So we see that the regression line, which is this blue line, shows the trend between feature 1 and feature 2. Feature 1 is on the x-axis, feature 2 is on the y-axis. So the shaded region also represents the confidence interval, indicating uncertainty in the regression estimate. Okay, and the scatter plot suggests a weak positive correlation between two features. Okay, the scatter plot suggests a weak positive correlation between two features, and the marginal histogram displays the distribution of each feature. So feature 1 is for this one, and this one is for feature 2. From the shape we can understand that it follows the normal distribution because it's like a bell here and here also. And since the regression line has a slight, as we see here, slight upward slope, it indicates that as feature 1 increases, feature 2 tends to increase slightly, but the relationship is weak. So as the feature 1 increases, the feature 2 also increases, but the relationship is weak. And the spread of points around the regression line suggests high variability, meaning other factors likely influence feature 2 as well. And this generally visualization helps in detecting linear relationships and assessing the strength of the correlation. So in this video we learned how to plot a joint plot with a regression line, and also we learned how to analyze the figure. Thank you for watching. Hello everyone, welcome back. In today's video we're going to learn about joint plot with hexagonal binding. So this is the figure. And first of all, we're going to learn how to plot this and then how to understand it. So here, in order to code this, we are having the necessary libraries being imported. Then we are creating the data frame. In order to do that, I call the data frame function from the Pandas library and I name it to be data. And then we are having feature 1 and feature 2 being generated normally following a normal distribution. The first one is following the normal distribution. The second one is again following the normal distribution with different mean and scale. Then we choose the white grid for our set style for better visualization. So you see that we have a white grid. And then we would like to have the joint plot. So I call the joint plot function from the Seaborn library. X equals feature 1, Y equals feature 2. So X equals feature 1, and the X-axis we label it. Y equals feature 2. And data from the joint plot function equals a data frame that we created here that is called data actually. And the kind is, because we would like to have hexagonal binding, we write down hex or HEX representing hexagonal binding. And the color map, we choose the cool warm. We can change it and customize it, of course. Then we are having the subtitle, which is joint plot with hexagonal binding. Here it is shown. So the subtitle function is called from the Matplotlib library to have the title. Then we are calling the show function from the Matplotlib library, and then when we run the code, we see this output as the figure. So the joint plot with hexagonal binding is used for visualization, visualizing, let's say, the density of two numerical features in a structure and grid-based format. So we are having feature 1 and feature 2. So we are having the visualization of density of feature 1 and feature 2. And the hexagonal beans group nearby points reduced in the cluster seen in scatter plots. And the color intensity represents data density. For example, the dark red region here indicate high concentration of data point. Lighter blue region show lower density, so we see them here. And the dark blue area indicate no data. Okay, so the dark blue indicate no data. So we started from the dark red. It's the high density region with a lot of concentration of data points. Then lighter blue regions, we are having that they show lower density, and dark blue with no data. And the marginal histogram provide the distributions of feature 1, this one, and feature 2, this one. So we see that the highest density is around this point, so something approximately -1 and 2, okay, or -0.7, let's say, and 2. It's the concentration and the highest density region of the data, and this suggests that the most data point cluster around this area. And basically this hexagonal binding is more effective than a scatter plot for large data sets with overlapping points. So in this video we learned how to plot a joint plot with hexagonal binding, and we learned how to understand it. Thank you for watching. Hello everyone, welcome to this video. In today's video we are going to learn about basic regression plot in Seaborn library, using Seaborn library. So we are going to learn how to plot this figure, and also we are going to learn what we can understand from this figure. So first of all, we're going to import the necessary libraries. Then this is the generation of data. I have a data frame, so that is called data. So I call the data frame function from the Pandas library, and the data frame is named data. Then we are having feature 1 and feature 2. So feature 1 and 2, both of them are normally distributed, while with the difference that the feature 2 has different mean and scale. Then we choose the white grid for the style because it has a better visualization. And now I would like to have the size of my plot. So first of all, the size is 8 by 6 inches. Then I call the regression plot function. So reg plot function is called from the Seaborn library. X equals feature 1, y equals feature 2. So x equals feature 1, you see the label. Y equals feature 2, you see the label here as well. Then the data that needs to be filled for the reg plot is filled with the data frame called data that we are having here. So this data is this data, and this data is for the, let's say, reg function. Then we would like to set the title. In order to set the title, we are having the title function from the Matplotlib library, and the title is basic regression plot or linear fit, let's say. Then we have the show function from the Matplotlib library to show and display our figure. So here is my figure after all. Now I would like to try to see what I can understand from this figure. In order to understand this figure, first of all, we need to know that this blue line here, this is the regression line that shows the trend between feature 1 and feature 2. So feature 1 is on the x-axis, feature 2 is on the y-axis. And the shaded region here near the blue line represents the confidence interval, indicating uncertainty in their regression estimate. And the scatter plot suggests here the data points. So each dot on the scatter plot is a data point, and it shows a weak correlation between feature 1 and feature 2. And also we see that there is a slope for the regression line, so it has a slight upward slope. It indicates that as feature 1 increases, feature 2 tends to increase slightly, but the relationship is weak. And we see that here, for example, the spread of points around the regression line suggests high variability, meaning other factors likely influence feature 2 as well. And also this visualization helps to detect a linear relationship and to assess how much is the correlation strength between these two features. So in this video we learned first of all how to plot a basic regression plot, and we also learned what we can understand from them. For example, this is the blue line is my regression line, and we are having the shaded part, and we see the spread of the points around the regression line showing the high variability, etc. Thank you for watching. Hello everyone, welcome back. In today's video we are going to talk about regression plot without confidence interval. So you see that we are having the confidence interval here. So the blue line is my regression line, and we are having the shaded blue as the confidence interval. But when I run the code, we see that we are having the blue line and also the shaded part. In order to not have the confidence interval, we need to slightly modify the code. So first of all, let's start with the code. We are importing the necessary libraries first of all. Then we are generating the data. We create a data frame. In order to create a data frame, we call the data frame function from the Pandas library, and the data frame is called data, and we are having two features, okay, two data sets. Let's say that they are normally distributed, but the second one has a different mean and scale. We choose the white grid for better visualization of our figure here, and in order to have a white grid we need to use the set style from the Seaborn library. Then here we have the size of our figure, so 8 inches by 6 inches. Then we are having the label of x and y axis. X equals feature 1, y equals feature 2, x equals feature 1. You see that the label is there. Y axis has the feature 2, and then the data for the reg plot equals the data frame that we created above. Okay, then we are having the title, regression plot without confidence interval. So regression plot without confidence interval is the title of this figure, and we call the show function to display our figure. But now when I run the code, we see that we are having the confidence interval, and the figure shows that with the these two features here, we are having, so when I run the code, you see every time that I run the code, a newly data is generated, and actually the figure shows a very low correlation between feature 1 and feature 2, and slightly we are having a slight upward slope for the regression line, showing that with the increase of feature 1, the feature 2 will also increase, but it's very weak. Okay, so this is what we understand. But how can we remove the confidence interval? In order to remove the confidence interval, we simply need to add this part of the code. So when we are calling the reg plot, simply we need to in the end we need to have ci equals none. When we are having that, meaning that ci means confidence interval, that stands for confidence interval. Confidence interval equals none. So when I run the code, in the next data that is generated here, we see no confidence interval, therefore we see no shaded blue here in the plot. So in order to remove the confidence interval, we simply can have this part of the code, confidence interval equals none. So in this video we learned how to plot a regression plot without confidence interval. Thank you for watching. Hello everyone, welcome to this video. In today's video we're going to talk about polynomial regression, or let's say order 2. This is also known as second degree polynomial regression. When a linear regression, which is the order 1, fails to capture the curvature or inflection in the data, a second order polynomial can fit the data better while maintaining interpretability. This is why sometimes we prefer to have polynomial regression. So in this video we are going to first of all learn how to plot it and how to understand it. First of all, we're going to import the necessary libraries like Seaborn, Matplotlib, Pandas, and NumPy. Then here we are having our data generation. We are going to have feature 1 and feature 2 to be generated using the normal distribution, but for the feature 2 we are having a different mean and a scale. Okay, and here we would like to create our data frame. So because of that, we call the data frame function from the Pandas library, and we are going to create our data frame, and the data frame name is data. Then for better visualization, we set the style to be white grid, so you see that we are having a white grid. Then we choose the size of our figure, so we would like to have a figure that is 8 by 6 inches. And finally we call the reg plot, let's say regression plot, but the function name is reg plot. We are going to call the reg plot from the Seaborn library. Here we are labeling the x and y axes. So the x-axis equals feature 1 and y-axis equals feature 2. So x-axis feature 1, y-axis feature 2. Then we are having the data of the reg plot to be equal to the data that we created here. This is the data frame called data. The right one is the data frame called data that we created above. The left data, the left hand side data, let's say, is the function from the reg plot. Okay, and then we assign order to be equal to 2, so the compiler knows that we are talking about the polynomial regression and not the order 1 regression. Then we set the title, which is polynomial regression order 2, and we use the show function to display our figure. So let me zoom out a little bit. When I zoom out a little bit, we see that the figure presents a polynomial regression order 2 analyzed between two features, so feature 1 on the x-axis and feature 2 on the y-axis. So first of all, the scatter plot we see here displays the raw data points showing a somewhat dispersed relationship between two variables. Okay, then we are having the regression curve, the blue line you see here, A second degree polynomial fit line is plotted here, showing a slight inverted U-shaped trend. You see, this is the inverted U-shaped trend. This indicates a non-linear relationship. For example, as feature 1, this is the feature 1. As feature 1 increases, initially feature 2 increases slightly, then decreases. This is the form of a U-shape. Okay, and then we are having the confidence interval, the shaded area. You see here the shaded area. That represents the uncertainty around the regression line. It's wider at the edges. You see, it's wider at the edges as compared to the center of the line. So it's wider at the edges where data points are sparser, indicating less confidence in the model's prediction in these regions. Okay, so in this video, first of all, we learned why do we need polynomial regression. We mentioned that when the linear regression, or let's say order 1, fails to capture the inflection of the data, we are going to plot the polynomial regression order. Then we learned how to plot this order 2. Simply in the regplot function from the Seaborn library, we assign order to be equal to 2. Then we learned how to understand this figure. Thank you for watching.